Okay. So a function has a few different key components. If these two words here, domain and range, are we familiar with those?
Yes.
All right. Can somebody tell me either another name or what we can consider the domain of a function?
Isn't the domain the x-axis?
Okay, right. So we could say, okay, x values, right? The x-axis if we're looking at it. Okay. We can also say it is the input. Okay, right? Have you heard that before?
Yes.
Okay. So then, one second, I'm just trying to match up attendance real quick. Okay, so the main x values x-axis. Okay, it is also known as our input, like we said. Is there anything else we can call it, or is that about it? I think that's about it. Okay, what about the range then? What is the range?
The output.
All right, the output. All right, I'll put that over here.
The y.
Okay, and right, it would be the y values and the y-axis. Okay, so equations and expressions, right, is a relationship between our domain and range, right? We have some function, okay, or some expression. We plug the domain into that function, right, and we get our range from that, okay? Another name for the domain is the independent variable, okay? Which means that, you know, it doesn't depend on anything. You choose your x values. I'll talk about that a little further later. The range we call the dependent variable, okay? It depends on what our x is, okay? So like we saw, you know, yesterday and on Monday with linear equations, we can pick whatever we want to plug in for x. There's no restrictions on what we can plug in. Our range depends on what we plug in originally, okay? So I put it up here, but I hope you guys are familiar with that, right? F of x. Right, we call that our function notation. Okay, and if you get to higher mathematics, okay, the domain and range are what we call sets. Okay, you don't have to write this down. Okay, but it's a set of numbers, right, that follows a specific instructions, or, you know, depending on our equation, right, certain rules and regulations. Okay. There's 4 ways to represent a function. Okay, the first way is verbally. Okay. You can have a sentence like a word problem. Okay. I don't know if you're talking about profit. Okay, if you have a company, population. Okay, if you're talking about science, things like that. The most common that we'll be doing okay, is numerically. That would be either tables, right? You have your X and your Y table, and ordered pairs. Oops, ordered pairs, right? So that would be like 1, 2, okay, 3, 4, so on and so forth. Okay, we use these fancy brackets to show that it's a set, okay? We can represent them, okay, on a graph, okay, on the coordinate plane, right? And that would be our x-axis and y-axis, okay? And then we could do it algebraically. Okay, and algebraically is when we have an equation with two variables, right? So x and y, right? X values and y values. Okay, so first we're going to talk about what makes a function special. Okay, we have a lot of different equations in math that aren't functions, right? They're just called expressions because a function needs a certain set of rules, right? And I'm gonna lay it out up here in kind of basic terms, and then we're gonna expand on it. Let me see. How do I want to say this? Okay. So for now, the very basic definition for a function is we're going to say every input has exactly one output, right? So every x value is only going to have one answer. So anytime you plug in something for the domain, right, it matches to exactly one range. Now that range can all be the same number. Okay, I can have every x value go to 2, right? If I plug in 1, I get 2. If I plug in 10, I get 2. If I plug in 100, I get 2. That's still a function because each x value only has one y value. If I plugged in x to an equation and I got y equals 6 and y equals 5, okay, that's not a function anymore. All right, so we're going to take a look at a few examples real quick. All right, I'll give you some time if you want to copy these down. All right, so here we have a table. Okay, this is just kind of called like a function map. We won't really see it outside of talking about functions. All right, so I'll give you a minute or two to copy anything down. Let me just. Okay, so for our first function map or element map or whatever you want to call it. Okay, let's dissect what's going on. All right, so in our domain we have 5 numbers. In our range we have 3 numbers. Okay, the domain could be every real number ever. Okay, the range, like I said before, might only be 1 number. It doesn't always have to match up exactly, right? So just be careful. Now notice here, you get a few different numbers going to the same range, right? 0, 1, 2, all go to 5. That's okay. That's fine. -2 goes to 3, and -1 goes to 3. That's okay. But our main issue here, okay, is at our -1. What's happening with our -1?
It has two outputs.
Right. So, okay, we're going to say that's not a function, right? And if they asked you to explain, right, you'd say exactly what you said. So, x equals -1 has two outputs, or right, it maps to two different numbers, right? In this case, 3 and 4. Okay, so that is not a function. Going over to this table, okay, again, we see, maybe a pattern, right? But what you're looking for is any of my x values repeat with a different number? Okay, do we see that here, or does each one of these have one separate output? Okay, in our case here, right, you got 0 once, 1, 2, 3, 4. So this, oops, I spelled that wrong. Okay, it is a function, right? And again, you could say this is very non-mathematical, but every x has one y. You could say something like that. Okay, like I showed before, we can also have ordered pairs, right? So if you see a string of ordered pairs, let me see if I have an example here. I don't think so. So you're going to have a squiggly bracket, and then you're going to see a bunch of coordinates. So it might be like 1, 9, 2. All right, so here we have a set, okay? Again, that's set notation. We have a set of ordered pairs. Now, what we can do, too, to make maybe, you're not comfortable with this, you can change this into a table or into a map, right? So remember let's do that together. So what would our domain elements be? What are my x values?
1, 2, 3, 4, 5.
All right, so your domain would be the numbers 1, 2, 3, 4, 5. Okay, and the range, what would our numbers be for the range, our values?
It'll be 9, 13, 5, 20, and 8.
Right, okay, good. Now, when we do this, right, we just like to put them in order so they don't have to match right now with what we have up here, right? So we're just going to put them in numerical order. So I have 5, 8, 9, 13, 20. Ooh. And that's a closed bracket. All right. So everything looks straight here, right? We don't have a number pop up twice, okay? If this was a 1, it wouldn't be a function, but everything looks good. Okay, so we do have a function. Okay, and then before we actually get into, actual equations, there's one other test that we can do, okay, if we have a graph. Okay, if we have a graph, if I said the words vertical line test, does that ring a bell for you guys? I'm seeing some yes, some no. Okay, so when we have a graph, we can use what's called the vertical line test. So what we do is we draw vertical lines on the graph, right? You don't have to draw them everywhere, but I'm just going to draw them everywhere. So as long as Okay, as long as we see those vertical lines only cross the graph once, okay, it is a function, right? So in this case, I just drew whatever here, all right, that would be, an x to the third. Each one of these lines only intersects one time, right? So we have a function. Okay, so now when we're given a function, now we have a few different ways that we can see if it is, I'm sorry, when we're given an expression, right, we can see a few different ways if it is a function or not. Okay, any questions about finding out if it's a function or not? About any of our rules that we just went over? Okay, so for the last few minutes, let me talk about okay, we're going to talk about domain and range specifically. Now, when we get into some higher things, we might have a situation where they tell us what the domain is. Okay, so you might see it, you might have seen it last year. Okay, so if you have, if you're looking at x squared, but for numbers greater than 0, right? For x greater than 0, that's telling you what the domain is, right? If you see something like right, x is between 2 and 10, right? They tell you what your domain is. Otherwise, we have what's called an implied domain. All right. So when we have normal polynomials, okay, so if I had a x to the n plus bx, right? So if I just had a polynomial with normal expressions, squareds to the third, to the fourth, to the fifth, okay, our implied domain we say is all real numbers. Okay, have you guys heard that phrase before, all real numbers? Okay, right. That's a lot to write. So what I'm going to use from now on is this symbol. Okay, it's an R with an extra line in it. That means all real numbers. Okay, now the range, it depends on our function. All right, so real quick, we'll talk about this more tomorrow when we have a little more time. But real quick, get rid of that. So if I had something like a linear function, okay, like we saw this week, or if I had something like x to the third, okay, my range is also all real numbers, right? It goes all the way up, and if I kept going up, it'd still be going, and it would be the same for going down, okay? If I had something like x squared, why isn't this not working? If I had x squared, what do you notice about the y values? Where do the y values stop?
At 0?
At 0, right? So our range wouldn't have any negative numbers, okay? Our range would be positive numbers, right? And I'll show you how we say that when we get further into it, okay? So the range depends, okay? Some instances where we got to be careful with the domain. Okay, when we have radicals, right? If I had the square root of x, do you guys know the rule with the radical? What can I not have underneath a square root?
A negative number.
A negative number, right? Okay, so our domain, in this case, we would say it has to be greater than 0. And actually, we can put an equal sign, right? Because it can't equal 0. The square root of 0 is 0. Right? So we'll say must be positive under square root. Okay. Right? So that's one instance where we got to be careful. Okay, another instance where we have to be careful is when we have a rational expression. A rational expression is when we have a fraction and a variable in the denominator. What's our rule? What can I never have in the denominator? What can we never divide by?
0.
0. So here, right, it's just one number we have to worry about, right? That x can't equal 0. Okay, so tomorrow I'm going to show you different ways that we can write the domain and range. Okay, and then we'll be looking at our different types of functions. Okay, so we'll start delving further into that. All right, guys, any questions about what we just went over? Okay, so just check Google Classroom. There'll be like a short, maybe 2-3 questions just on basic stuff like this, kind of like an exit ticket for you guys. All right, so nothing heavy. That'll be due tomorrow, and we'll continue with this lesson tomorrow. All right, and I'll put up, I'm recording this, so I'll put up the video on Google Classroom as well. All right, so if you guys don't have any questions, that's all I got for you guys today. Enjoy the rest of your day, and I'll see you tomorrow.
Thank you. You too. Bye.
Bye, Mr. Murray.
Bye.
Bye, guys. Have a good one.
You too.